Okay, we are going to be looking at Learning Target 19. I can apply the properties of integer exponents. Before we do that, we need to understand what exponents are. Exponents are, when we're working with repeated multiplication, we use the same number multiplied by itself, and we use exponents to say how many times we are multiplying that single number by itself. So for example, if I have 4 times 4 times 4, that would be 4 times itself 3 times. So it would be 4 with an exponent of 3. That 4 is called our base, and then the exponent is clearly called the exponent. And we would read this value right here as x to the power of n, or to the nth power. So looking at our examples, if I have 11 times 11 in expanded notation as exponential notation, that would be 11 times itself twice, so that would be 11 squared. And then the value of that would be what 11 times 11 is, which is 121. Looking at number 2, I can see I have 2 times itself, 1, 2, 3, 4, 5, 6, 7. So that would be a base of 2, because 2 is multiplied by itself 7 times. So 2 to the power of 7. And 2 to the power of 7 we get is 128. Number 3, we have negative 5 multiplied by itself. So our base is negative 5, and it's multiplied by itself 1, 2, 3, 4. So that would be negative 5 raised to the 4th power, and negative 5 to the 4th power is 625. Okay? When we have fractions, it's the same thing. Our base here is 1/4. 1/4 is multiplied by itself 3 times. If you want to put it in parentheses, that is okay. And 1/4 raised to the power of 3 is let's see, it would be 1 over to the third, 1 over 64. And we'll talk about how we would do that math in a bit. Number 5, notice I have 2 different bases. I have 7s and I have 4s. So this would be 7 is multiplied by itself 2 times, and I'm multiplying that by 4 multiplied by itself 3 times. So you'd have 7 squared times 4 to the third. Okay, 7 squared is 49, and then 4 to the third. Together we would get 3,136. Okay. If we jump down to number 8, we see we only have variables. However, my variables, it's the same one, so I still have a base of A. That gives me 1, 2, 3, 4, 5, 6, 7. Oh, did I run out? 1, 2, 3, 4, 5, 6, 7, 8, 9. A to the 9th power. Okay, and there is no value on that because we do not know what A stands for. Number 9 is interesting because notice how you have x times y together. You don't have to split it up as x raised to a power and y raised to a power. We can keep x, y grouped as a singular base, and it is multiplied by itself 1, 2, 3, 4, 5 times. If we jump down to number 11, I see I have some constants. I have some 9s. 9 times itself 3 times, so 9 to the 3rd power. And then that's going to be multiplied by k. 1, 2, 3, 4, 5, 6. 6k, so k raised to the 6th power. And 9 to the 3rd power would be 729, but the k to the 6th power would have to stay the same. Okay. 13 is an expression. All right, so we would have to keep the expression together. We don't want to split that up, keep it in the parentheses. But how many groups of that expression do I have? 1, 2, 3 multiplied by each other, so I'd raise it to the third power. And then lastly, number 14, again, I see I have two different kinds of bases. I have 6's, and then I have a plus b. So I have 6 times itself 3 times, so that would be 6 to the third. And then a plus b times itself twice. So 6 to the third we have is 216 times a plus b squared.